back to my channel. Today we're going to work on another recursion problem called climbing stairs. The question states you are climbing a staircase. It takes n steps to reach the top. Every time you can either climb 1 or 2 steps. How many distinct ways can you climb to the top? So let's look at example 1 of n equal 2. There's 2 ways, so you can either take 1 step and then 1 step, or you can take 2 steps. And then let's look at example 2. For n equals 3, there are 3 ways. You can take 1 plus 1 plus 1 step, 1 plus 2 steps, or 2 plus 1 step. So this is also another classic recursion problem, but to avoid the duplicate function calls from the classic recursion, we can solve this using recursion plus memoization. So for memoization, we usually have like a hash table, so we can define our cache out here using a dictionary in Python. And for what's already known, like the base case, it's just if we take just 1 step. If there's n steps, then we just have 1 way to reach it. If there's 2 steps, there's 2 ways to reach it. 1 plus 1 or 2, and so on. So with our cache defined, we can start writing our recursion. So if n is already in self.cache, then we can just return self.cache and directly. And if it's not, then we can try to do a recursive call. So we can say self.cache n equals self.climb stairs n minus 1 plus self.climb stairs n minus 2, right? Because there's 2 ways we can either climb 1 or 2 steps at a time. And we want to calculate all of the combinations of taking 1 step plus all of the combinations of taking 2 steps. And ultimately return it to store that in our cache n. And after this returns, we can just return self.cache n. Yeah, so this is how I would solve this question, and the time complexity would be O of n, and the space on the function stat call would just also be O of n. Like the cache also goes up to O of n. And let me know if you have any questions, and thank you so much for watching.